The next one I'm going to do is chapter 4, number 42. And this one says, a bicycle wheel is rotating at 50 revolutions per minute. So that gives us the initial velocity is 50 revolutions per minute. Okay. And then, when the cyclist begins to pedal harder, giving the wheel a constant angular acceleration of 0.5 radians per second. So they're giving us alpha is 0.50 radians per second squared. So they gave us omega naught, they gave us alpha. And then we want to know what is the velocity in RPMs 10 seconds later. So we want to find omega 10 seconds later. And then part B, we want to find how many revolutions does the wheel make during this time. So we want to figure out the number of revolutions. Okay, so we have omega, we have initial omega, we want to find a final omega, we have alpha, and we have time. So let's just use this equation here to figure out what the velocity is. So for part A, I'm just going to say omega is equal to omega naught plus alpha t. So omega is just going to be equal to 50 RPM. Can I put 50 RPMs in? No, I have to convert this. So this is revolutions, so I'm going to have one revolution on the bottom, 2 pi radians. And then per minute, which means minutes is on the bottom, so 1 minute divided by 60 seconds. So multiply by 2 pi and divide by 60 gives me my initial, and I get 5.2 radians per second. So it starts out at 5.2 radians per second, plus, and alpha needs to be going the same direction because it says it's speeding up, so I'm going to make it positive. 0.50 times the amount of time, and it says 10 seconds later. So times 10, and we get omega is equal to 10.2 radians per second. And my blue pen is about half. Radians per second. But they didn't ask for that, they want this to be in revolutions per minute. So we have to convert that. Remember, to convert that, we just do the opposite. Seconds is on the bottom, so they go on the top, 60 seconds. Over 1 minute. Radians is on the top, so radians has to be on the bottom over 1 revolution. So I multiply by 60 and divide by 2 pi, and I get 97.4 revolutions per minute. Did I do that right? Sorry, I'm going to do a quick check here to make sure I didn't make a mistake. Times the by pi over 2. Yep, that's right. And then it asks, how far do we go? For part B, so this is the answer to part A. For part B, I'm going to use the first one. Theta is equal to theta naught plus omega naught t plus 1/2 alpha t squared. Initial position is 0, right? So theta is going to be our initial velocity, which we have right here, 5.2 times 10 seconds plus 1/2 of alpha, which is 0.50 times 10 squared. And you get that theta is equal to 77 radians. But they want that in revolutions, so we got to convert again. 2 pi radians, 1 revolution, so divide that by 2 pi, and we get to 12.25 revolutions. And that's the answer.